Okay, this is our Arduino robot project for Meen 1000 uh, members being Chris, Steve, Adam, and Taylor. So the goal for this project was to design an Arduino-driven robot for our hypothetical client that can successfully navigate a pretty rudimentary obstacle course, find a black square on the ground by itself, and also do that on a pre-programmed approach. And the design of the robot must uh, allow it to travel up and over and down a ramp. Those are our goals for this. Get my mouse out of the way there. These were the first sketches we came up with during our design process, early stage. Obviously, one of these iterations is more serious than the other, simply because we came up with the first iteration found on the left, and we were pretty sold on that. You can see we'll be using it's labeled as an infrared sensor in the picture, but we'll later be using an ultrasonic sensor, probes, and a bump detection sensor also. During early stage, we had some early design questions that we needed to answer before we moved forward. We needed to know how many wheels do we want and why, and how will we guarantee good traction? Well, the how many wheels had to do with we don't want to get high centered on the ramp, but we also want to make sure we can supply enough power to keep the robot moving because we figured after all the motors, components, 3D printed elements, wires, all and batteries, all of those make that on there. We would have a fairly heavy robot relative to the motors we would be using. So that was a concern, and we also wanted to guarantee good traction. We came up with the decision to use four motors, one motor per wheel, and then traction was gained with sandpaper being cleverly wrapped around each wheel. Uh, we figured that would satisfy our need there. Our original manufacturing plan featured the four motor setup mentioned with four wheels and two MOSFETs, one MOSFET per side of the robot, per lateral side. So one MOSFET circuit with two 9-volt batteries connected in series, so 18 volts. One MOSFET circuit with 18 volts running through it per side of the robot was our initial approach. We had a fifth 9-volt battery for power supply to the Arduino itself. All the materials consisted of our body, which is 3D printed along with our wheels. You can see in the bottom right. Electrical tape, color sensor, which we decided to use a color sensor instead of the probes, ultrasonic sensor instead of the probes. We felt like that was a little more practical, and our color sensor to obviously pick up the black square on the bottom of the track. Our SolidWorks renderings were pretty simple. What you see on the left is the body of our design. I'll actually go back a tab. You can see the red just above the wheel right there. That is our body, and obviously the blue being our wheels. This is our code. Uh, Steve played a good part in this for us. It has some pretty essential pieces that you'd expect to see in a robot. You obviously have your uh, initial statements that uh, set up your motors, proper effects when sensors are tripped. Obviously, when the color sensor detects black, we want it to stop. And pretty simple code there. Code diagrams uh, and circuit diagrams really were used to help us maintain some sort of a direction. When we were first putting this robot together in our little coffee shop we met up at, we kept running into the fact that we didn't necessarily have a home base to come back to. It seemed like we worked on one thing and then another. We'd work on one thing, get it fixed, move on, and then that other thing we just barely worked on kind of tended to get jumbled. Maybe wires got unplugged and we had to go back. So these code and circuit diagrams really helped us a lot during the manufacturing and assembly process to keep things straight. Some notable roadblocks we ran into during the construction and testing of the robot had to do a lot with the motors. Um, I compare this to the gain problem you face in one of the later assignments in the 1035 class, where the motors are just so intense right at the start of the program and throughout. So, whenever direction change is needed, it's a very, very jerky, very sudden start stop change of direction. So, we were having issues with that. Um, it seemed like we were also getting over voltage uh, with our original setup with two MOSFETs. We would be trying to get a motor to work over here, and then another motor would start running seemingly randomly without explanation, or other things would start going off. So it was there we decided to switch from a two MOSFET setup to a four MOSFET setup. So each motor had its own MOSFET that seemed to um, disperse voltage much better. We actually blew a not only a resistor but also an Arduino. Sadly, during our two MOSFET iteration, so we switched to four MOSFETs, and that worked out very well. The circuit diagrams also helped a lot for overvoltage, and the color sensor we actually didn't end up having any of those between the three kits in our group, any color sensors whatsoever. So we had to order a third party one, best we could hope for, and try to figure out how to work with that. So we were just running into a couple issues trying to get that to work. Eventually, we figured it out. Okay, so this is our pre-programmed run. For both of these videos, I'm not going to talk too much over them because it seems like the audio fights with me. So I'm just going to let this one play and we'll discuss it. Perfect. Oh,
We need to angle it a bit right.
yeah, I think the oblong wheel is making it. We'll push. Blow on it. That's a course default. That's not the robot.
The robot's doing great.
To the right. No.
Oh, it's Come on, baby.
Yay! And the autonomous run.
Those orange wires supposed to be?
I don't know.
Okay.
The wheels were turning, man.
No.
Uh-oh.
Oh! Please.
Oh man.
I don't know about that.
All right, so some obvious issues there, but nonetheless, it's an engineering class for a reason. We got to figure this out eventually. So, what we could have done differently, the biggest issue I guess, conclusion we could draw from this is the fact that we did not use stepper motors. Uh, it's leaving me off the top of my head the type of motors that we used, but they seem to behave in a way in which the motors favored top speed, but not necessarily torque. As you can see in the autonomous run, the attempt at least, it couldn't even get up the ramp, which was fairly shallow. Build we intentionally didn't really build it too steep because we knew it was a fairly heavy robot relative to the motors. Anyway, to begin with, um, and because we don't have enough torque at the start, obviously, once it would reach the wall on the autonomous attempt, the ultrasonic sensors read stop motors because you're close to an object. But since those motors just simply do not have a lot of start and stop torque, it just could not stop in time when it ran into the wall. So bounced off there. Another issue we came across was the modular design. If you can see just above this red body, we had our batteries sandwiched in between the body, the 3D printed element, and our breadboard. Um, in hindsight, looking back on it, it was a very, very poor modular layout design. It made rewiring, resoldering our wires onto new, fresh batteries fairly difficult. We had to pick the whole thing off, and of course, to do that, we'd had to disconnect our wires. So anytime we needed to change out our batteries to get a fresh power source, rip the whole thing off, put the new batteries in, solder them, put the breadboard back on, put the sensors back on, rewire everything. It was just a really, really big hassle that wasted. No, I wouldn't say wasted, but just took up a lot of time. That could have been a lot more time efficient. And overall tidiness, um, we did have time constraints. We do have to submit this at a deadline for our clients. Uh, Overall tidiness of the robot could have been much improved. Also, I did add on the bottom right corner here, compartmentalization was pretty good. Um, if you notice in the autonomous run, we had a resistor blow when it tried to come to go up the ramp. When we first had a resistor blow earlier in our design and building stage, our MOSFET circuit was completely integrated with the rest of the breadboard. So when our resistor failed, it went through straight through the MOSFETs to the Arduino, and Steve actually lost his Arduino, completely fried it. But that's probably our proudest moment. Chris was able to come up with a way to compartmentalize the MOSFET circuit. You can see that smaller little breadboard here on top of the bigger one. That allowed us to localize our MOSFETs, our all four MOSFETs completely. So if we had something go wrong with the MOSFETs, it wouldn't damage the rest of the breadboard assembly and save our Arduino. So we were very proud of that. When that second resistor blew, the Arduino on the robot in that video was completely safe. So we'll talk to that. In conclusion, we attempted to design a robot, an Arduino-based robot that would have met our clients' needs. Unfortunately, it did not, and expectations were left short. But there were bright spots. Overall, the group's consensus was that we were successful in some areas with room to improve in others. Thank you very much.